Welcome to Unity Coroutines. Unleash asynchronous power. In this comprehensive video, we'll delve deep into how coroutines can fundamentally revolutionize your Unity game development, making your games more responsive and efficient. We'll cover everything from the basics to advanced best practices, ensuring you have a solid understanding. Coroutines are truly special functions within Unity that empower you to perform tasks over an extended period, allowing for precise control by pausing and resuming their execution at very specific, predetermined points. This capability is fundamental to creating dynamic and interactive game experiences. They are absolutely crucial for effectively spreading computationally intensive tasks across multiple frames, which is vital for preventing your game from freezing or stuttering. This ensures a consistently smooth and highly responsive user experience, even during complex operations. Common and highly effective uses for coroutines include creating incredibly smooth and fluid animations, implementing precise delays for various game events, and efficiently managing complex asynchronous operations such as loading large assets or handling network requests without interrupting gameplay. So, why exactly do we need coroutines in our Unity projects? The standard update function, while essential, executes code every single frame, which can quickly become unwieldy and inefficient from managing time-dependent sequences or operations that span multiple frames. Imagine a scenario where a tank needs to execute a precise sequence. First, it turns, then it moves forward a certain distance, waits for a specific moment, and finally fires its weapon. Managing this intricate sequence solely within the update function would necessitate incredibly complex state machines and numerous flags, making the code difficult to read, maintain, and debug. Coroutines offer significantly cleaner and more readable code, making it much easier to manage intricate time-based events and complex sequences of actions. This leads to more maintainable and understandable game logic. Crucially, coroutines are designed to avoid blocking the main thread of your game, which is paramount for maintaining responsiveness. This ensures your game remains fluid, performs efficiently, and provides a seamless experience for players, even when background tasks are running. Let's dive into the fundamental syntax of coroutines. A coroutine is uniquely declared as an IEnumerator return type, which is a key indicator of its ability to yield control back to Unity's main loop. Inside the coroutine method, you'll utilize the powerful yield return statement. This statement is what allows you to pause the execution of the coroutine and precisely specify when and under what conditions it should resume. To initiate and run a coroutine, you must call the start coroutine function. This function takes the coroutine method as an argument, effectively telling Unity to begin executing your time-based task. Here's a simple yet illustrative code example that brings together all these concepts, demonstrating how a basic coroutine is structured and executed within Unity. In the start method, which is called once when the script is enabled, we initiate our coroutine by calling start coroutine. This is the entry point for our asynchronous operation. Our mycoroutine method is defined as an IEnumerator, signifying its coroutine nature. It begins by logging coroutine started to the console, indicating the commencement of its execution. Then, the line yield return new wait for seconds is encountered. This statement pauses the coroutine's execution for exactly 2 seconds, allowing other game logic to run during this delay. After the specified 2-second delay has elapsed, the coroutine automatically resumes its execution and proceeds to log coroutine ended to the console. Let's observe this precise sequence in action within the Unity editor. Unity provides a rich set of yield return options, known as yield instructions, which offer powerful and granular control over precisely when and how a coroutine resumes its execution. Yield return null is a fundamental yield instruction that pauses the coroutine until the very next frame. This effectively executes one step of your coroutine per frame, making it ideal for gradual, frame-by-frame operations. Yield return new wait for seconds pauses the coroutine for a specified duration, measured in seconds. Importantly, this instruction respects time.timescale, meaning it will slow down or speed up with your game's time settings. Yield return new wait for seconds real-time also waits for a specified duration, but critically, it ignores time.timescale. This makes it incredibly useful for UI elements or other time-sensitive operations that should proceed at real-world speed, even when gameplay is paused. Yield return start coroutine is a powerful instruction that allows one coroutine to wait for another coroutine to fully complete its execution before the first coroutine resumes. This enables complex sequential task management. Yield return new wait for end of frame is a specialized instruction that waits until all rendering processes are completely finished for the current frame. This is particularly useful for operations that need to occur after all visual updates have been applied. Yield return new wait for fixed update waits for the next fixed frame update. This is absolutely crucial for synchronizing actions with Unity's physics engine, ensuring consistent and accurate physics calculations. These diverse yield instructions collectively provide incredibly powerful and flexible control over the precise timing and intricate flow of your asynchronous operations within Unity, enabling highly dynamic game logic. Let's apply this newfound knowledge to a highly practical and common example: smoothly fading a UI element, such as an image or text, both in and out of visibility. To achieve this, we'll first need to declare a public image reference in our script, which we'll assign in the inspector, and a fade duration float variable to control the speed of the fade effect. In our start method, which executes once at the beginning, we'll initiate the fade-in process by calling start coroutine. This will smoothly transition the image from fully transparent to fully opaque. Our fade image coroutine is designed to be versatile, taking two float parameters, start alpha and end alpha. These values define the initial and final transparency levels for the fading effect. Inside the coroutine, we initialize time-elapsed to 0 and retrieve the current color of the image. This color will be modified to adjust its alpha component during the fade. The core of our fading logic resides within a while loop. This loop continues to execute as long as the time-elapsed variable remains less than our predefined fade duration. Within each iteration of the loop, we increment time elapsed by time.delta time. Then, we use math, lerp, to smoothly interpolate the alpha value between start alpha and end alpha based on the elapsed time. We then apply this newly calculated alpha value to the image's color and immediately yield return null. This pauses the coroutine until the next frame, allowing the fade to occur smoothly over time. Finally, after the loop completes, we explicitly ensure the alpha is set precisely to the end alpha value. This guarantees that the UI element reaches its intended final transparency state, preventing any potential floating point inaccuracies. Observe how the UI element gracefully and smoothly fades in over the specified duration, creating a polished visual effect. This seamless transition is entirely thanks to the precise timing and control offered by our coroutine. Understanding the coroutine lifecycle is absolutely key to effective use. We initiate coroutines by calling the start coroutine method, which tells Unity to begin managing their execution. To gracefully stop a running coroutine, you have two primary options. You can use stop coroutine by passing either the method name as a string or, more robustly, by providing the IEnumerator reference that was returned when the coroutine was started. Additionally, for scenarios where you need to halt all active coroutines on a specific monobehavior component, you can conveniently use the stop all coroutines method. This provides a quick way to clear all ongoing asynchronous tasks on that component. It is considered a best practice to store a reference to your coroutine when you start it. This allows you to precisely stop, pause, or manage that specific coroutine later in your code, offering fine-grained control. It's important to remember that coroutines automatically cease execution if the game object they are running on is either disabled or completely destroyed. This built-in behavior helps prevent orphaned coroutines and simplifies cleanup. Now, let's transition to discussing some essential best practices and valuable tips for utilizing coroutines effectively and efficiently within your Unity projects. First and foremost, avoid excessive use of coroutines. While powerful, having too many active coroutines simultaneously can introduce significant overhead and potentially impact your game's overall performance, leading to slowdowns. A key optimization technique is caching wait for seconds objects. Repeatedly creating new wait for seconds instances, especially within loops, generates transient garbage, which can trigger frequent garbage collection and cause noticeable performance hiccups. Instead, declare a wait for seconds object once as a private static read-only field and then reuse that single instance whenever you need a delay of that specific duration. This significantly reduces garbage collection overhead and improves performance. Always ensure that your coroutines have clear and well-defined exit conditions. Failing to do so can result in infinite loops, which will inevitably freeze your game and require a forced shutdown, leading to a poor user experience. For larger and more complex projects, consider implementing or utilizing a dedicated coroutine manager. This centralizes control, organization, and debugging of all your coroutines, making large-scale asynchronous operations much more manageable. While coroutines are incredibly powerful and versatile, it's important to understand how they compare to other asynchronous techniques available in Unity and C# to choose the right tool for the job. Unlike the simpler invoke and invoke repeating methods, coroutines offer vastly finer and more granular control over timing, allowing for the creation of highly complex and sequential action sequences. Compared to C#'s more general async/await pattern, coroutines are specifically designed for Unity and integrate seamlessly with the engine's unique lifecycle and mono-behavior components, making them often more intuitive for game development tasks. Coroutines are frequently the most appropriate and efficient choice for time-based events that require direct interaction with Unity's game loop and the mono-behavior lifecycle, such as animations, delays, and sequential game logic. In summary, coroutines are an absolutely invaluable tool for expertly managing time-dependent tasks within Unity, ensuring your game remains responsive and never freezes, even during complex operations. Throughout this video, you've gained a solid understanding of their basic syntax, explored the various yield return options, and seen practical applications like smoothly fading UI elements. We also thoroughly covered their essential lifecycle, from starting to stopping, and discussed crucial best practices for achieving optimal performance and maintainability in your projects. Now, it's your turn to apply this knowledge. I strongly encourage you to experiment with coroutines in your very own Unity projects and see the power they bring firsthand. Remember, practice makes perfect, and truly mastering coroutines will significantly enhance your game development skills, allowing you to create more dynamic and professional games. If you found this video to be helpful and informative, please take a moment to like, share it with your fellow developers, and subscribe to our channel for many more in-depth Unity tutorials and valuable content. Thank you so much for watching this tutorial, and we wish you happy and productive coding in all your Unity endeavors.